All right. All right, so today's presentation, wait, is that where it starts? No, that's not it. Okay, that is the first slide. So today we're talking about Azure Data Factory, and my name is Murali Subramanian. I'm the presenter and co-chair with Julie Bloomquist. We're in the room here, provided by our favorite people here. Our sponsors. Wait, that's the next slide. I'll be right there. But okay, our favorite people out here sponsoring us. Thank you so much, Andy. Oh, Doherty. Oh, this is not even the right. Is this the right one? Sorry. Yeah, it's not Covenant. It's Doherty. Here, let me just fix that. That is. Oh, upcoming. Oh, got it. Yes. Yes.
We're being sponsored by Doherty Business Solutions.
Solutions. Sorry about that.
And
So,
Andy, would you like to give a little talk
Andy?
about?
I don't hear you.
Thank you. Great way to come out and learn about a variety of topics. We're happy to host and sponsor this. We are a consulting company with lines of service spanning data and analytics, software architecture, engineering, and business analysts. There's a new name for it. But anyway, yeah, we're happy to sponsor it, and thank you.
Thank you. Not sure why we didn't have that earlier. I apologize. So next month, we're still trying to figure out our speaker and content. So stay tuned. It's going to be sponsored by Covenant, and we're still going to be able to use part sponsorship from Doherty using their facility. So really appreciate that. Usually our meetings are on the second Tuesday, so you can kind of look forward to that. Next time it's September 10th. PAS 24 is November 4th. I think we are a little bit out of the discount time frame and everything, but in case you guys are interested, please feel free. You'll have a lot of MVPs and great content out in PAS during the entire summit. Some of our SQL Saturdays and Data Saturdays around the world. Feel free to take a look at them. I wish there was one in Paris this past month instead. That would have been nice. Got a SQL Saturday there. We could have accomplished two things at the same time, but I mean, I thought most of the people were staying in the Olympic village, and whoever, when people thought they were not very good and they started leaving the athletes, we could have filled those positions. It's not a big deal. I don't mind sleeping in a cardboard in Paris. It's fine to reduce cost. Okay, today's presentation is about Azure Data Factory. So a few things we're going to talk about: how to make this more general utility data factory. That way we can create artifacts that could be used for multi-purpose data movements and orchestration. I am the speaker, and I have all this experience. Let me move over to mine. Let me actually do it this way. All right, so this is my slide. Okay, so we're going to talk about Azure Data Factory, the artifacts, orchestration, deployment, and this is a part of the user group for SQL Server and BI. I know we're kind of getting a little bit in between areas where we are primarily focused on SQL Server and BI, but we use like cloud resources these days, so we don't talk much about SSIS extract or anything. So think about mainly data factory, data movement, and stuff like that. So that's me. I have 13 years of experience in BI and stuff, all these good things, lakehouse, data modeling, backend database developer. So whenever you guys are having the database admin group talks and you're talking about the developers, that's one of I'm sitting back there listening, trying to make sure we can make our relationship better. I do have Epic clinical EMR expertise with their data model and stuff like that. So been in healthcare the entire time. So that is the brief me. So basically, I'm gonna show you a generic architecture. This is what we kind of use. You don't have to use the same. It's kind of if it sparks some interest to you to design your architecture to be as doesn't necessarily always stay this simple. But I mean, we do have a Databricks for our final lakehouse, and also we're trying to move our data being sourced from our EMR based on-prem database to we have a copy of that in our Databricks, so we're trying to source it from there. And whenever we have like slices and dices of data, the data movement for that from the Clarity Databricks happens using ADF. We move it, and I mean, when I go show you our ADF pieces, you'll be able to understand this a little bit better too. But also, we use Azure SQL, of course, as a part of our development for applications, so we can kind of containerize it a little bit, and have, I mean, to go into our Databricks, we do the medallion architecture, we do have a storage, and then we use Unity Catalog, and that pushes it through. And all of these components are touched by GitHub and DevOps. So GitHub, we store our code. That way we have a code repo, and then our DevOps pipeline, Azure DevOps pipeline, does a CI/CD for us and picks up the code from related GitHub. Like we have a repo for ADF, we have a repo for our Azure SQL, we have a repo for our Databricks, and so on and so forth. So it pushes it through between dev and prod environments. So one of the key things I do want to, why do we do this? Why are we trying to make this multi-purpose utility tool? I mean, one of the key things that happens to developers is, we start developing something in an agile fashion. Once we are in that groove, it is hard to go back and fix anything. So as a meme, I got this from one of our somebody. I mean, I do have the source here. You can go look it up. I like that article that he had written about it too. We always start with something. Agile doesn't let you think too end-to-end process before you start it as much as you would like to. So once we start, it's hard to stop because normally we are set up, our resources are set up in a way that we respond only to critical problems or planned agile items that we didn't think about. So even if we have betterments, that could make our lives better, we are unable to take time to do that. So it's better to think of these items that I'm going to show you today if you're already not. But in the future, if you're doing another domain, another data factory for your whatever reason, you might be able to implement all of these. So just think about it. So set it up. So that way you can reduce and recycle all those pipelines and artifacts. ADF orchestration table. So I know I mentioned 3 things that I was going to talk about with the ADF artifacts, but the way we are making it multi-purpose is going back to utilizing various tools to do the job in the right way. So one of the things is using tables. Does it have to be tables? Doesn't have to be. You could keep like config files to do the same. In this case, since we all love relational databases, and we are very used and familiar with it, we created these things in tables. So, and also as a enhancement down the road, we're gonna build an application to input the data instead of having DMLs sitting out there in the repo. I'm gonna show you DMLs and everything, but so what are these items? So one is the orchestration item. So we could have multiple orchestration items, but whatever you're trying to orchestrate between, which I'm going to show you in a minute, is one of the key base items. It's like worker node. An orchestration group is like the executor node. Think of it that way. It just creates like a group of orchestration items. This is how we built ours. And then the relationship between, sorry, I forgot trigger. There's trigger. So each of the triggers within ADF for the same pipeline could be stored in this table, and which we have still not started using yet because we have a single trigger at the moment. But when we use that trigger, as well, we use the relationship tables to go with it. So what does these all mean? In a second, I'm going to show you what the data model itself kind of looks like. Okay, so that's kind of how it looks like. So I was talking about the arc item. So think about the arc item. So this arc item are these 3 items. So one we have set up to go between, one was set up, this EDL item arc was set up to go between any source to our core. For whatever applications we are building in our domain, we have an Azure SQL I told you about. So whatever goes from that source to the Azure SQL, or from within the Azure SQL itself, between stages, we have set up like depot, staging, and fact or dimension. So to do that cleansing, we have those 3 layers. So the landing, which is our depot, and then staging transforms and cleanses it, and then our final facts and dimensions. To go through those items, we have information in here, which again, once I go through this, I will show you how it looks like, so you have a visual idea as well what that means. And then once I show you the records of these, then I go through the ADF pipeline piece of it. I'll show you how that pieces together, how we are able to use it to multi-purpose our pipelines. So that is the EDL item arc. We did create a couple others, one for Databricks, because we were becoming Databricks heavy. We're trying to do stuff, but we still wanted to use ADF as our single orchestrator. So we would put our Databricks related job, just simple information that we could then make our pipeline look up and run. The same thing with this ETL output item mark. I know it's not very super intuitive names, but it made sense to us. The ETL output item mark are the ones that are extracts that go to external vendors, or even sometimes within our own internal other teams when we send it to anything other than what we are a department of. So in this case, as you can see, some of these have relation tables. So the way we built it was, like I said, going back to here, the org group is the overall kind of like the executor node. So all these items fall under certain groupings that were in this grouping org table. So yeah, very simple. And again, when I show you the DML, you should be able to understand a little bit better. So we have normalized it to the extent we would be useful. And also, you see on top we have the trigger. So table for trigger, and then whenever we have the Databricks job or the ETL item org, we have the trigger for each of the trigger, because the same pipeline, same data movement within, like for instance, we have a provider dimension. The provider dimension can come from multiple sources at various triggers. But when it's moving within Azure SQL between depot, staging, and dimension, it's going to be that very same pipeline that's going to be triggered. And so the trigger itself could be like at 7 a.m. for one source and 9 a.m. for another source. That relational table will be able to identify that same pipeline for the depot to staging movement will be called at 7 a.m. and 9 a.m. So that's kind of how this relationship works. Again, this is a little abstract right now. Let me show you the DML in a minute. And that's between trigger and org item. The same thing in case we, for whatever reason, have a utilitarian job in Databricks that we decide to run multiple times, multiple triggers. That's the relational table that we are going to use to find that, use it. These are all good in theory. How does it actually look like? So let me show you the DML. One of the key things is, I mean, this is VS Code. I'm just showing you the code repo. One of the key things, I was going to show you the data itself, but my SQL Server Management Studio, I still haven't started using Azure Data Studio that much. SQL Server Management Studio is a light background. This is dark theme. So I'm prefer dark theme. That's why you guys are all seeing this now. So one of the key things is, the DML I was talking about, which I'll start with the ETL item. So in the DML, how I've done this, I'm not going to go too much into why I wrote it a certain way, but you can see these list of items that tells me, it's Clarity source prep. What that means is we have a pipeline set up to run stored procedures in Clarity. We have, again, another pipeline that runs the Databricks jobs, right? So it's similar, but this enables us to then first run a stored procedure, and then it slices and dices data, and then it puts it in tables back in Clarity. And then the next pipeline grouping gets it from Clarity, those tables that I created using the stored procedure, and then it moves it to depot. So when I go to ADF, you'll see all the activities, how this happens and everything. But for here, that's the grouping. Like I'm moving between a source to my Azure SQL, or between Azure SQL, so depot to DIM. In certain cases, for whatever reason, we decided to have depot to DIM directly. again, that's a totally different topic of warehousing and why we did it a certain way. But that's a group. Depot to staging dim, depot to staging fact. So dimension tables have staging tables, fact tables have staging tables, and it has to be in a certain order. So to be in different orders, we put it in separate groups. So these all go into that grouping table, this grouping arc. This temp table holds everything, all the source object, destination object. When I go down a little bit, you'll see, for instance, this is the Clarity source prep. So in Clarity, it's running a stored procedure. You can see it's null values before that and null after that. You can see that it is connected to a trigger orc list. What that means is I can have, when I eventually have multiple triggers, for instance, one is a 7 a.m. trigger, let's daily, I call it daily 7 a.m. And then I call the next one daily 9 a.m. It would kind of work like this. So this list would be, I mean, have split string and everything, so it'll throw it into the trigger table automatically. That's the kind of goal and idea and how that will work. And you can see in some of these other cases, I have the starting table and ending table. So again, when we go to ADF, you will see how and why these items are used. But the key is you have a starting table somewhere. It doesn't matter if it's from Clarity source. It could be an API. If I am calling, if it is going within Azure SQL, I'm just calling the, like for instance, is going between depot and staging. So discharge destination depot to staging table. And you can see how our naming itself is very, redundant, still very intuitive when you look at it. So it's pretty obvious. So it's in depot, both logical and naming we have separated out. Again, these two tells from which table to which table, and this one tells us what stored procedure it is using for that transformation. That's the DML for the actual item itself. Yeah, we have a list of those items. Generic. We have registry specific and stuff like that. We also store some for data that goes from Azure SQL to Databricks. We just use the system tables within, because this deploys to Azure SQL. Just getting the list of all tables that we care about are in all the schemas to be written to Databricks. But here you can see that grouping, we also have an order. So initially, when we created this order, our idea was to have a single run, single pipeline that will call everything and it'll run based on that order. But as we went through our development, that was a little too much, trying to fit everything using our, trying to resolve all the problems with one pill kind of scenario. So we branched it out a little bit even after that. So when we go to the ADF pipelines and artifacts, you'll be able to see that. So this order itself also, however, helps us understand where it starts and where it ends. So we know that, depot to dimension, the one case, let's forget about that outlier case, because I know there's going to be a debate about that. But depot to staging and then dimension starts at 1,000 or 10,000, sorry. And then staging to dimension. So depot to staging for the dimension tables starts first, and then the staging to dimension follows up next. What this helps us know, giving it the order, first all the dimensions are populated, and then it goes to any dependent dimensions if there are. If one dimension is dependent on another one, what is it called, degenerate or whatever dimensions. And then the other one is fact. So finally fact, that way all the dimensions are populated first, and then fact is able to use the dimension values within it. So ordering and another item is active. So active, if something is there or not, we soft delete it. That way, if there is a record that says a movement used to happen and then we soft, it's not there anymore, it's just soft deleted to this active Boolean. And then trigger, again, so the item itself is merged into the main ETL item, and then there's trigger. Again, currently we don't use multiple triggers, we just have a single trigger. So that's kind of how the DML for this item orchestration works, and that again is how will be used in our ADF pipeline. Question? Sure. Yes, sure. Sorry, one second. Are you able to, Julie, can you check if you can hear his question? If not, I'll repeat it. Okay, go ahead. Mm-hmm.
So the shots, like triggers that you set up, those will look like milliseconds or something. Are those wavelengths or are those?
Good question. Triggers, I'm sorry. These are actual ADF triggers. Oh, sorry. The question was about what those triggers mean. These triggers, thank you for the question. That was not very clear. There are triggers in ADF itself, which kicks off a pipeline. So I'm talking specifically about those triggers. The number, oh, the numbers that I was showing you were the order of that. Sorry. Question. So are these numbers for a time delay? No, sorry. I don't know if it somehow looks like it is time. It is definitely not time. It is an order of how, in which order is the pipeline going to run. So dimension is going to run 5,000, and you'll see there's a row number too that I'm using to add to it. So if I have 10 dimensions, it'll be 5,001, 5,002, 5,003, 5,004. So it'll run. It is just to run in an order that I wanted to run. And the 5,000, 10,000 is just to give it enough space between each other. Because if I say this is 100 and I have like 20, I call this 150, and for some reason I have 151 pipeline, then that's gonna mess it up. I might have to redo it. So kind of. Good question. So this is gonna be, so two parts. One, this is going to be, this we deployed in our Azure SQL that was in our main domain. I would suggest keeping a separate orchestration metadata Azure SQL location, place, server, sorry. This is deployed to a server, but that is all this information, the records that you're seeing here are used in Data Factory to trigger something or to run something in a certain way. Direct, yes, yes. I'll show you that in a minute when we go to the ADF part. That's what I was gonna, yeah. So these are, yes, numbers in which it gives us the gap is not any scientific gap. It's just to make sure we have enough space between two groupings. I'm sure there won't be 4,000 pipelines. If we do have it, might be. I don't even know if Google has 4,000 pipelines or Microsoft has 4,000 pipelines. So, that's kind of the idea. But when I again go into the showing that other part, you'll be able to understand what these mean and how they all come together. Okay. So that's the DML. That is the data model. So So those are the tables that we use to help us orchestrate and make these multipurpose tools. But what does that mean? How do we do it? Before we go into that, let me show you our ADF. It's in the same spot, isn't it? Okay, so let me show you our ADF, and I'm gonna pick an example and help you understand what that means. How do we do this? All right, so to be able to do this, before I do go, I'm gonna go back and forth, so it's kind of helpful. Going kind of backwards, because pipelines are the ones that you build and you see under multi-utilitarian. And then pipelines use datasets use link service. Global parameters are used in datasets or pipelines. So everything you would see. But the idea to make this multi-purpose for pipelines, two main things that you're going to see in our all of our pipelines. The pattern that you see is using a lookup to get a list of values to loop through. The second one is for each, the activity that'll do a copy or movement of data between one place to the other. Sounds very simple. Let me go back here. For instance, H starts data movement. So I kept saying within our Azure SQL data keeps moving in. So we created a utilitarian one. But let me actually show you the orchestrator. So the entire orchestrator, again, one of the key things, we couldn't have multi level of nesting within ADF, which kind of made us go through orchestration slightly differently and having actual pipelines like this. But you can see that in our case, we have data movement from, like Clarity pre-ingestion prep, which means it runs the stored procedure in our source. Our source that is on-prem Clarity, or in this case, in our Databricks. So if we are pulling it from Databricks, that's what's going to happen. And then in Clarity or Databricks, it's going to run that stored procedure, slicing and dicing data and putting in a set of tables that we can bring it into our Azure SQL. So, so Clarity to HR, that's our domain name. So we pull it from there. It goes into depot and stage. So these are compartmentalized, you can see. And in this case, this is the data movement between within our Azure SQL itself. Okay, so for instance, if I look at that particular pipeline, which is moving from depot to stage, I know I didn't go too much into the layers that we created, and that is not a scope of this, but I'll just give a brief idea again. Depot, for any layers, if you guys have worked with, depot is the landing layer. So anything that's coming from outside, it's held in depot. It has all string values and everything. Our staging has the transformed values. So any dim IDs and everything will be transformed and to the right data type and stuff like that. So we do the transformation in that staging. So you can see in our pipeline itself, we have the initial lookup. Again, that's going to be always the pattern. Lookup for each, lookup for each. And of course, kind of good housekeeping for ADF in general, you're going to have like failure notifications or silent errors sent to your Teams channel or wherever, however, like email, whatever you guys want to do. But the key is lookup. Let me look up the lookup. Show you. It's not very big. But in my lookup, one of the things I'm using is that ETL item org that I just showed you. And see, I'm using specific depot to staging. So this tells me I'm going to create a list of items that look that has like those values. So if I copy all of this, oops, sorry, did I press something else? Copy. If I do the copy, let me move this over here. And let me paste that. You can see this doesn't run like that. Execute. Okay, so you can see it's giving me that list of items that I'm looking for whatever. I mean, I'm going to use these items in my case, but so this load dim, it's a stored procedure. So between depot and staging, I'm using this stored procedure. Between staging and dimension, I'm using this stored procedure. So my here. So my items in the for each is gonna get the output of this lookup activity. And before I even go there, I want to quickly point out another thing. So you can see I'm using a data set that uses generic items. I'll come to that in a minute. But so the query itself, I have to look up the list of items, the for each. You can see how it is for each between multiple activities. So again, there are a few things here. A couple of things I'm not going to talk too much in depth about. One is the stored procedure to audit batch. If you have any kind of auditing logging, you could do it different way. We decided to do it in a relational table instead of just doing a log file. This is just to see when what was written. That way we could build something out of it at a later point in time, based on, I don't know, whatever metrics, how long did depot to staging take for this pipeline and stuff like that. So the audit itself, don't worry about it too much. It's just, again, tagging if this pipeline ran successfully, how long did it take, and so on and so forth. But the key thing is for us, for this stored procedure, stored procedure call itself is to look at the item. Remember, I mean, depot staging, SP name. So you can see the depot staging SP name is right there. So if I was doing like, category dimension, then it's first going to run this. It's going to tag all that. Using that stored procedure, it's going to move the data. It's going to tag that it ran fine. It is doing a condition for how it, if in case it fails. That's another thing I don't want to really get too much into. But let me open that too. The same case here, I'm using that staging to final SP name to figure if I have that final dimension movement, depot to, stage to dimension movement, then I have this. And then, we click that. Did I click it? Okay. So same idea, concept, stored procedure for audit. Don't worry about all the other stuff. Just this main stored procedure that runs to do the data movement. So we do have stored procedures that ran our data movements. So again, utilitarian for all these values that you see here, all these 16 rows, these 16 tables, actually 16 times 3, actually 15 times 3, 45, actually 30, because it's only moving to stage and to dim or fact. 30 plus 131 tables that gets done using the 16 rows and this one pipeline that does all these data movement. So again, utilitarian, there's one pipeline, heavy lifting, 31 different movement. And what does that mean? Again, here you see, in this case, your question of that 5,000, 10,000, what does that mean? So it knows that there's a number I have given it in my DML. So you can see first dim category is going to run, and then diagnosis, and then discharge disposition. It's going to go in that order. So that way, I mean, in this case, I really, at this point, we didn't need a specific order within the group. So it's just doing a row number based on the name. But if I needed specific order that is different than this, then I just give it the order and number back in the DML. Then it's able to run the first ones, up top, and then depending on the dependencies and stuff like that. So that is, again, for each. This is within our Azure SQL, but it's pretty much the same if I'm bringing it from elsewhere too. For instance, this one we run, this is from Clarity. So it's Clarity 2A stars. You can see it's just looking up again. It's a slightly different lookup. It's just the only thing that's going to mainly change is the grouping. So the rest remains pretty much the same. And then for each, again, everything same pattern, lookup and for each. So the for each itself has the audit batches and stuff like that. In this case, we're trying to tag the audit batch as well. And this is coming from Clarity, so there's a source for that, and sync. Pretty much similar concept. However, when it's coming from outside, remember our landing zone is depot. So in our lookup, and I'm looking it up, where you look up, oops. And I'm looking up only for the names of the tables. So so if I ran just the source to depot, where say it could be an API, or in this case we have access to Clarity database, so we can read the source tables. I mean, you should have read access, otherwise you won't be able to get it from the source, any kind of source. So it just goes from one table to the other within those schemas. It's pretty obvious. That's what we use within our for each too, to tell it it's coming from a certain place in the source. It's gonna have that table that it's getting it from, table name that comes from the source table name, and then takes a second of flag, I guess. But then when it comes back, to the sync, you can see the table name here, goes to the destination table name, goes into the table. So it's pretty straightforward. We have all these things set up using the orchestration tables. Any questions? I'm gonna go to the next one. If not, data sets. Where are you? Here, data sets. So you might have seen when I showed that all of these source syncs and all the activities, use something called data set. So one of the key things when you do to multi-purpose this, create or parameterize the data set. That way, what you can do is, you see here, let me move this a little bit. I don't need to see this either for the time being. You can see my source and sync. I have parameterized it with schema name, the table name, server name, and then the database name. I should have ordered it the right way, but you get the idea. So, server and database, we are calculating it based on the pipeline. Again, this could go into when we have multiple sources, the idea was for us to change this to, instead of calculating it here, just doing it in our database itself and storing it in the ETL item arc. That way, the server and database names are stored there. And based on dev or broad data factory, the server names and database names will come through. The reason we are not using like server name, database name, which you can get from sys.servers and sys.databases in the Azure SQL, we're storing it, but it's not only the Azure SQL that we care about. Going forward, we'll have multiple sources. So the source, database, and server name is what we need to store, which is why we don't use that in case that's something you're thinking. Yes, right. You can look up your data lake, or yeah, you can store it exactly. The same thing with schema and table. We just had a separation for schema and table for good measures. We don't know when that might break or have a problem. So instead of doing dot table names, we just did a. But that's the same thing with source too. So it's coming from Clarity. We have specific server names, and then the schema and table that we're getting it from. So the data set, I'm gonna show you. Actually, let me show you the sync data set. So if you see the data set, again, it's very simple. Creating parameters would be great. That way, you can use that same parameter within, because the data set uses a linked service. And linked service, in our case, we have also parameterized. As a hint to the next thing, you'll see the reason why in a minute when I show you that. The data set itself has parameters that can feed into the linked service parameters. So two of the key things that the linked service require are server and database names. Server and database names. And for the linked service to work, you have to give it the table name. And you can see the reason we have schema.table name. Excuse me. Otherwise, if we had a single parameter, then we would have to like calculate it here, do a split string using dynamic expression here. We're like, no, we won't do that. So we have these data set parameters that feed into the linked service, which you can see. Another thing of making it multi-purpose is to parameterize the linked service. So if I go one step further, you can see in a linked service, the two parameters are server name and database name. If I hit it on the linked service, you can see it's using, again, server name and database name as its own parameters. So I created parameters, server name and database name, things that you think are helpful to be parameterized. For anything else, like you could have parameterized the secret name or the key vault name or anything like that. We didn't see the need to do that. If you're using multi-tenant keys, more than single key vault that you want to switch between for various sources and stuff like that, you could use various domains and various sources, then you could have done that. In this case, our domain was specific and we had a single key vault for that domain. So we just looked at it. So things that are helpful, you can always keep parameterizing it to the necessary extent. Here, necessary extent was only server and database name. Again, we use key vault. You use direct password, that's going to be a little bit management and stuff like that. So be careful. So that helps. You see how it flows. I have to parameterize my linked service. So they show up here in my data set. And my data set has the parameters. So when I put it in my pipeline, I can see and utilize that same data set to trigger 31 object. Yeah, it's not this one, but the one before that, 31 table movement between depot, staging, and then artifact. So multi-purpose, recycle, reuse, basic, lookup, for each. And of course, your main either copy data in this case, or in other case, I use like a stored procedure run, direct stored procedure run if I'm just moving between the same layers. So those are the items for for these three artifacts. The last one is global parameters. Oh, sorry. Last one is global parameters. Global parameters can be used within your pipeline and to describe something like your tenant ID. Can be used to have your dev environment ID. Hold on, I'm gonna have to move this slightly to this side before I show you that piece, just to make sure none of our IDs, sensitive information show up. Okay. Okay. Because I know. You can probably see part of it, but not all of it. Okay. I think it should come through the same way. Okay, it did. Nice. So you can see, can't see the entire value, but you kind of get the idea. We store things, subscription, except for tenant, I think everything else are environment specific. One of the key things also many people might not tend to use in Data Factory is this feature. Where are you, feature? Oh, sorry. Click the, sorry, wrong place. Oh, sorry, wrong place. ARM template right here. So this feature that does include the global parameters in ARM template. So keep this in mind for a minute. When I go through the next set of items, our deployment, you'll see how this can be used and how this helps you there. This is one setting that that'll be very helpful. So remember to use global parameters for dev to prod wherever you can use it, like within a pipeline and data set. Edit parameter config, something that is very useful. A lot of people might not be using it. One of the key things we added some, whenever you create a dev version of a pipeline, you want a specific property to come through. That, for instance, recently we had triggers. Trigger stop time is something that was very essential for us to know, because in dev we didn't want those triggers to go off daily. We wanted a stop time, but in prod we wanted them to go daily. We didn't want them to be stopped. So our deployment, to be able to know that, as you can see in this ARM template definition JSON, it has all these artifacts, like the entire data factory artifact, the pipelines. So what this means is, within a pipeline, if there is a property for its properties, type properties, catalog, server, endpoint, then it's going to show up in your ARM template. If I have a pipeline trigger, let's say in this case, trigger that I was talking to you about, I wanted to capture that end time. So if I had the stop time, which is in type properties, recurrence end time object. So we added this. When we added this, this shows up in our CI/CD deployment, which when we go to that in a minute, I'll show you how to use it. But then I can capture that property in dev when I'm using my GitHub. My entire data factory code repo is based on GitHub, right? So now I am going to use this particular property in my ARM template to switch between dev and prod. So remember, like link services, we added a couple of things to the link service too that are not by default added. So just keep an eye out on it. Sometimes this is the thing that people might not know or not use as often. Like even data sets, you could just change things here. Like I said, the calculation that the dynamic expression we did in the data set to calculate this server name versus database name between dev and prod, we could use some aspect of that here and stuff like that. So this is another important. So this checkbox for the global parameters, this ARM template, whenever you see something in your GitHub repo definition, then you'll be able to use it. So let me show you what that means. Where are you? Okay, so since we're there, so our global parameters are used in ADF pipeline and also DevOps pipeline as the next item. So we use a DevOps pipeline, Azure DevOps, to go between dev and prod using our GitHub repo. I'm going to show you our pipeline, parts of how we have done it. But our pipeline itself uses these important aspects that I would encourage you to try as well, if you're not already using it. I mean, in our case, Azure PowerShell is what we use. You don't have to use it. I mean, it depends on the type of task that you're doing. For our ADF, we are using Azure PowerShell. And actually, again, remember one of my old thingies. So we're using like an older version of the PowerShell. So we're still at this level. We're like, we need to update it, but we have not had the time to update it. So we still have the wheels in our hands, didn't put it in. So not the data, correct. This is a yes, deployment pipeline. So we move the same data factory artifacts from dev to prod using this pipeline. So as a quick thing, so again, override template parameters, something I'll show you in a minute too, and variable groups are what we use to switch those values between dev and prod. Okay, so I have everything here. Where is it? No, not that. Okay, this must be it. Okay, yeah. So this is our ADF release pipeline. So we created a pipeline that looks at our GitHub repo. So that's our current trigger. Normally, if you're not very familiar with it, what people do is they have like a master or a main branch. I think everybody's going to main branch. And then within GitHub, so actually, let me also show you GitHub ADF. So in our, oh man, exactly at this time, you have to ask all these questions. Okay, nice. So in ADF, our main branch is going to look like this. It's going to have information about entire data factory, integration runtimes, link service, pipeline triggers, and all those stuff. Not all nice things. So when I'm creating a branch and I'm working on a pipeline, I'm creating a pipeline that's going to be in that branch. And then once I merge it in our ADF PR, it's going to be in the main branch. And then once that happens, we have created a branch called ADF publish, and it's a read-only branch that is protected. So that's what this uses. Where is it? Gosh, I can't. My eyes are so crossed right now. There is a setting somewhere out here that shows you what the branch is. Oh, good. Thank you. So it's telling me it's coming from a specific branch. Collaboration branch is main, publish branch is ADF publish. So ADF publish is like a pristine branch that we try to hold that nobody can directly write to. So once you merge your code, so whenever you're making changes to the pipeline and code is generated in the backend, or you can do vice versa too. You can do a code generation and then you will see the pipeline here in your branch. And then once you merge after your PR, it goes to the main branch. And then once it's main branch, we go here and publish it. Currently there, I mean, you cannot publish it from any other branch. If I'm in main, then what I can do is I can click on this publish. It'll what it will do when I click on this publish, which I'm not going to do right now. It is going to push main all the items in the main branch to ADF publish. In ADF publish, you can see there are not the same list of items. I'm not going to go too much in depth about this, but the list of items you see are very specific. Only the template factory and the parameters factory. This is a really huge diff. It's going to be like tens of thousands of lines, if not more. It's storing everything about your data factory. The ARM template that we just saw, that I showed you, to click that little thingy, that is all stored there. So if you guys are not familiar with it, where are you? ARM template, yeah. So all the configs that I showed you right now all mean all that information are all stored in this ARM template for factory. If I open this, again, it'll have some IDs that I don't want you guys to see. But when you create one, you'll be able to see the same items as well. So from this ADF publish, our deployment pipeline, where are you here? What it does, it looks at that particular GitHub repo. It says, okay, it got published to ADF branch, and I'm looking at my ADF publish branch. So my GitHub itself will trigger it. Come on, don't ask me to sign in now. Okay, we'll kind of skip that for the time being. But there's a trigger that tells it to look for the ADF branch. Hold on, give me 1 second. This is going to be kind of annoying, isn't it? Give me 1 second. Sorry about that. Come on, ask me to refresh. Okay. Are you fine now? Okay. I think it's just a little hangry. All right. That is why it was not working. So it's looking at my particular GitHub repo, and it's looking at the particular branch that I just said was the publish branch. So I have that publish branch being looked at here. So it's an automatic trigger. So whenever I can click the publish in my data factory here, main branch is gonna dump all that into the pristine ADF publish branch. As soon as it does that, it's gonna say generating ARM templates. So when that happens here, automatically this would be triggered. So then my deployment trigger happens here, and it says, okay, I'm gonna push data, whatever this asks me to do. We do have an approval. Not gonna go too much into the approval, but validation, stop and start. So start, important. So we have an ARM template deployment, Azure PowerShell just to start and stop. I should have thought about it. So in my PowerPoint, when I said this, using PowerShell, we use Azure SQL PowerShell, Azure PowerShell to deploy our Azure SQL that way too. We used heavily our Azure PowerShell. Here it's pretty small, just having a code that says to trigger the data factory triggers to stop or start. Okay, in this case, our validating, usually we do the validation to make sure things are all validated. It's almost like the same thing that you do here using the validate all. So the code itself looks at our resource group and everything, and the template, it's stored within DevOps. I'm not going to go too much into that. One of the key things, actually two of the key things I was going to talk about from here are the override template parameters and variable groups. So you can see our override template parameters. If I click on that, you'll be able to see a list of parameters. Most of these are parameterized already. So you can see my data factory name. If I did not parameterize this or use the variable group, it would actually tell my parameter, data factory name ADF 8 stars dev or prod, and so on and so forth. So what this tells me is this is telling our deployment pipeline that there is a parameter that we declared or we used as a part of the ARM template. That ARM template is going to switch in this deployment between dev and prod. So the dev value will be replaced with the prod value that I'm giving it. For instance, I mentioned that the trigger that I have, I want it to not work in dev. I want it to have a stop time, but I want it to work in prod, so it has to continue going. So in this case, we added it in the ARM template, like I showed you. And then here, the daily trigger property, this automatically shows up when there's a new pipeline, when there's a new property to show up. When you publish it, it'll automatically show up. You cannot hard code it. If you do, it'll go away if it's not the right property name. So when you add this, when you see this property, I force it to look at the variable group. In this case, I created a variable to hold that value for the end time. So I'll show you. I mean, in our case, whenever we're deploying it, we'll just have an end date of like tomorrow or like yesterday for the triggers. That way in dev, they don't trigger. But in prod, we have like 3000, 1231, 3000 or something like that. And, you know, guessing there won't be a developer asking us about it at that point of time. So, but how do you use this? So if you see that I'm using it as a parameter or a variable from the variable, so you can see it says how to use it. So we just use that same idea. We created a variable group. Do I already have that open? Yes. So I already have it open, the variable group, and I have kind of moved it away so you don't see the exact values again. But in my variable group, which I will go back, are that's the service connections. What was the variable group? Yeah, like my library. I'll go back in 1 second. My library. So you see the variable groups that I created. I'm going to click into it, but that's how it is. But if I click into it, it'll look like this. And you'll see that I have, to make it easier on myself, I have some of them named very specific. So if I had a data set and its property with the specific property name that I'm trying to tag, I call it the same thing as the variable name. So I can just use it in my in my override template the same way. So all I would have to do in some of this, so for instance, the Azure SQL DB connection string will have the same name as a variable name. So I could just copy paste that just out of just for some ease. And whenever we're looking at it, we don't have to think about it too much. It's so straightforward. But some things that are very common that can be used for multiple properties, like this trigger or this trigger, the end time is going to be the same. So we call it just trigger properties, right? The property name's the same, and then end time. So then we know that's going to be used for all triggers. Again, go back here. You see the library itself has trigger properties reference, and then the end time is like January 1st, 3100. So if it was yesterday, when it goes to prod, automatically the end time is going to be 3100. This is how it works. The deployment itself. This is how you use override templates and the variable groups. That's the variables how you create. Again, this is our case. We use the same names. You don't have to use the same names as the override template parameter name. You can call it whatever makes sense to you, and you want to store this that way. And you can also, once you create these libraries, this variable groups, you can use it between multiple pipelines. So if you have multiple data factories, and you could use it amongst them too. So those are all the utilitarian multiple items that we use to make our lives easier going between the deployment, making it multi-purpose. using those same data sets, linked service to accomplish multiple data movements. I think that is pretty much what I wanted to cover today. Any question? Yeah.
So there's a question online from Ezekiel. It's he has a question for Murali when we're done with the presentation. Can you talk about the methodologies you use to tune and optimize the pipeline itself, independent to tuning the data source and the database objects the pipeline uses? For example, I imagine you regularly think about simplifying and or reducing ADF artifact steps.
Yes, that's a great question. I would like to think about it in two different. I want to think two parts of it. One, since we're all SQL savvy, I take everybody have done some kind of SQL tuning, query tuning, performance and stuff, performance tuning and stuff like that. So think of our pipelines taking time to do stuff. One of the key things in ADF versus SSIS packages, we knew memory was used. Somehow it's kept in the back ends, and we were able to see when data movement happened, like 500 rows happened out of 10,000 rows or whatever. We have some limited back-end visibility within ADF. So for anything specific to ADF, there's very little performance tuning that we do. There might be better people who can talk about ADF related things. So that's one part. The other thing is, like you said, reducing the number of artifacts and using like um, um, parallel runs and stuff like that. So when we have these artifacts, these 31 artifacts that I showed you, or in this case, let's say 9 of these data movements from our source, there's no reason why we can only get the fact table first and not the dimension table. So we pull everything simultaneously. So it runs parallelly. Now, some of this might take a little bit longer and stuff like that. So we do consider things like what is our limit that we can push to have these run parallel versus what can we do, like what can we not do parallelly, what has to happen in an order. So you see the difference between that and the order itself giving you that order in certain cases. The grouping itself, the grouping arc that you have seen itself giving you that order that needs to happen only serial, not parallel. And then within that group, you can have it any which way ordered and can run parallel. So think of those kind of parallel runs, reducing the artifacts based on just the use of the or the purpose of that pipeline itself. And also, again, still there's one, I did mention this during my presentation too. So, nesting is not available in ADF. There's only like one level of nesting at the moment. So you cannot have two levels of nesting. Like you cannot have for each inside of for each. So that is not allowed. If and when it happens, that would be great. That would help reduce some of this and make it a lot more generic, and you can have reduced number of artifacts too. Hope that answers your question. The for each, the nesting, I think they have some. It causes some problems. There's an entire article about that I read whenever I was trying to do this initially 2 to 3 years ago. That time, so yeah, they were saying it's for a specific technical reason that they didn't enable nesting. But there are so many people like you and I who want this to happen. So I'm hoping this will happen sometime. They can overcome that. In ADF, or are you talking in general programming? In ADF, it is not available. When you mean only in ADF, I don't know what that means, but in general, in ADF, you cannot nest for each inside another for each. So what that means is when I want to have a grouping for each and then another for each inside that grouping, so I have a bigger utility, a single orchestrator built for an entire structure and purpose that is not available at the moment. Now, can we do something else? Yes, that's what we're doing at the moment. We have to manually set those orchestration differently, which is, yes. So, yeah, right, I get it. Yeah, so our orchestration itself, if we could have for each inside for each, all of these pipeline runs would be a single lookup and for each pipeline. So it's just all the inner activity doesn't have to be in a separate pipeline for that reason. But that's what we could have accomplished if it was there. And we did have to create separate utilities for that purpose and then have a single orchestration on top of it. Yeah, any other questions? Sure. Awesome. Thanks. Good to know. Good to know. Thanks for the question, Ezekiel. All right. If there is not much else, I really appreciate you guys for hanging on and listening to this informational stuff. Hopefully you can implement it somewhere if there are parts of this that could help you optimize your entire data movement orchestration deployment process. So, thank you. Thanks.